Okay, so let's see. So for Mendelian, that monohybrid cross, the first one. So what? Excuse my fingers, but Mendel took a tall plant and a dwarf plant. The best part about pea plant is they were all homozygous in nature. Homozygous means both the alleles were dominant in nature in case of tall. It could have also been a capital T and small t. In that case also it would have been dominant only, because the capital T, which is for tallness, would have actually hidden the dwarfness part. So that's why this would have also been a tall plant. However, in case of pea plants, they were homozygous. So capital T and small t, small t. So these are the parental generation. So this is the parental generation. So when you are crossing between these two, so what are the gametes that can come? So from capital T, say for example, if I had crossed between capital T, small t and small t, in that case, the gametes that could have come is, one was capital T, the other one was small t. From here, only one type can come, which is small t, right? So that confusion got eased up because of the pea plants. They don't have the heterozygous thing. They only have homozygous ones. Either it's homozygous dominant or homozygous recessive. So this is homozygous dominant tall plant, and this is a homozygous recessive dwarf plant. Okay. Now from here, the gametes that were formed, was capital T, and from here the gamete that was formed is small t. No other gametes can be formed, right? You understood that. Now what we do is, now when these two gametes came together, right? So if I am crossing, the gametes have to come together. Then only the crossing happens. So when these two come together, what we get is a heterozygous dominant plant. So this is actually a, can you see? I hope so. Heterozygous dominant. So it will be tall only, but it is heterozygous because it has got both dominant and recessive one, but the recessive allele will not express itself because the dominant allele is there. Alright, now it's like daddy and mummy, and you have a baby. Right, so these were the gametes. From the gametes you get this baby. So daddy and mummy and baby. Now what they have done is, or rather what Mendel has done is, he took two of these things. So there were many such. It was not that one only was made. One capital T, small t was made. There were thousands of capital T, small t which were made. So he just took two such. So capital T, small t and capital T, small t. Now this time you cannot put the cross sign here. You cannot give that because it's not crossing. They're like brothers and sisters. You cannot cross between brothers and sisters. Ethically not right. So what you do is, you call that selfing. Okay? Selfing. We're not taking selfie pictures, alright? It's selfing, not selfie. Okay, so now from here the same process starts. So this is your F1 generation. F1 generation means first filial generation. Please don't write generation like that. I'm just doing that to shorten the time. Alright. Now from here, what are the gametes that can come? One capital T gamete can come. One small t gamete can come. Right. From here also, a capital T gamete can come. A small t gamete can come. Because both are there. So that's why two types can happen. Now when this selfing is actually happening, then what happens? Gamete from one parent will unite with gamete from other parent. Like here, gamete from one parent united with gamete from other parent. The same thing will happen over here. So if this gamete united with this gamete, we get a homozygous tall plant. If this gamete united with this one, we get another homozygous, heterozygous tall plant. If this gamete united with this gamete, we will get another heterozygous tall, because capital T and small t, we always write the capital first and then the small one. And if this gamete had united with this one, then we would have got a homozygous dwarf plant. What we need to understand, these two gametes will never get united between each other. It will always, one from here will unite with other from there. It's like this is the daddy one, this is the mummy one. So within daddy unity cannot happen, or within mummy unity cannot happen. So it cannot be like this. This T will not unite with small t, capital T and small t. It has to be one from here and one from there. Now which one will combine with which one is absolutely a chance factor. So all these 4 types that are formed are the 4 chance factors that have happened. So about these, what we can say is, from the point of dominant and recessive, or pure and hybrid. Okay, so which one are pure? Pure is this one, capital T, and small t. And hybrid, which is hybrid is capital T, small t. So homozygous dominant, homozygous recessive, heterozygous dominant. Now if they ask for the ratio, what is the genotypic ratio and what is the phenotypic ratio? So if I'm talking about the genotypic ratio, so what is the genotypic ratio over here? Genotypic ratio tells you about accurately what has happened over there. So for in case of genotypic ratio, what you get is homozygous dominant tall is to heterozygous dominant tall is to homozygous recessive dwarf. How many such you are getting? One, see, homozygous dominant tall, only one is there, so capital T, so that is 1. Heterozygous dominant is these 2, so capital T, small t, that is how many you got? 2 of them, right? So 2. And in case of homozygous recessive dwarf, that is 1. So small t, that is 1. So the ratio, actually you do not write this step. From here you directly actually come to the ratio is 1 is to 2 is to 1. Or rather, another better way of writing is genotypic ratio. What is your genotypic ratio? That is capital T is to capital T, small t is to small t is equals to 1 is to 2 is to 1. So that is your genotypic ratio. Now what is your phenotypic ratio? Phenotypic ratio is looking at the plant. You cannot tell that this is a dominant one, homozygous dominant one or a heterozygous dominant one, right? You just see it is tall. You cannot say that this is tall because it has got dominant homozygous dominant genes or heterozygous genes. So that's why your phenotypic ratio is tall is to dwarf, because you do not know about their genetic makeup. You can only see the phenotype, that is outward appearance. So tall is to dwarf. So how many tall were there? This was tall, this one is tall, this one is tall, because all 3 of them have at least 1 tall allele in them. So 3 is to 1 dwarf, 1. That's it. I hope I could explain to you. Love you, beta. And if anybody else is seeing this, love you all. Best of luck.